Okay, so now that Fuel has been installed properly, we can actually now log in on the public IP, the web UI IP, which previously was 80 in our case, port 8443. So it's going to be a self-signed certificate for HTTPS, but at least it's secure. So you have the Fuel landing page. I've set everything to default. I haven't changed anything, so admin, so I can log in. So and here we are. So this is your initial landing page for Fuel itself. Fuel kindly reminds us to change the default password. We can do that at many stages. You know, even if an environment is deployed, so which is a kill environment. The environment here is actually, this page is where all your OpenStack environment will be. So basically, if you have, I don't know, if you're lucky, and then you have an environment, you have 30 servers. Let's say you have 30 servers, and you want to chunk them out in, multiple small, fully isolated OpenStack environment. You can actually create multiple environment from one fuel node. So maybe you have like three environment of 10 servers. And you can do your test. So it's not a problem. So you can manage that through Fuel itself. It's not one fuel per environment. Of course, it needs to be an environment where the nodes can all be discovered by Fuel. So if that's not possible, then it's an issue. So then you might end up having like multiple fuels installation. Um, it's mostly linked to the HTTP discovery, also by the fuel node itself. So some layer 2 gateway sometimes might actually work in passing that information through, but it might actually need a few tweaks, but still possible. So going through that interface here, you have the release section. Release section is just going to show you exactly what's been installed on your fuel node. So if we have like 2015.1, which is the 7.0 release, when 8.0 comes, or if I had 6.1 upgraded to 7.0, then those would show also here. Plugins is all the plugins installed from the Fuel CLI earlier on. Basically, you log on SSH in your fuel node, and then from there, you can use the Fuel CLI to get those plugins. So if you go on the Mirantis website for fuel plugins, where everything, all the plugins have been like tested, validated per version, so 6.1, 7.0. It could be a storage plugin, network plugin, or like a DLMA toolchain, an LDAP plugin would be listed here. So you log in on the SSH fuel node. You log in on the fuel node with SSH. Sorry there. And from there, basically, you can do a curl wget and get the package from the website and load it in your fuel node. And from there, you just do a fuel space plugins space dash dash install space and the file of the plugin itself. You hit enter, it's going to install it. Once it's installed and okay, it's going to actually show up here. And I have the Elasticsearch, I have my Kibana server, I have the Grafana server, I have the collector, and I have the alerting. So this is basically Elasticsearch, Grafana, and Nagios plus a collector installed as plugin. I have the Firewall as a Service plugin option that's there, VPN as a service, and also an LDAP plugin. In this case, be aware that the LDAP plugin that I'm using is something that's no longer on our website because they had some issue with it, so they pulled it out. But just to show you that actually that plugin exists, so if you want LDAP or backend authentication for Keystone, the plugin exists itself, and you can load it up. So and it will come back to the website quickly before MOS 8 or maybe within MOS 8 release, so by the end of the month. Support tab, pretty straightforward. You can actually send your usage statistic to Mirantis. You can contact support. You can go to the documentation. You can download diagnostic snapshot. This is really useful for support. And linking to support is that if you are a customer of Mirantis, you're paying for support, you can actually put your account information here. So you connect your Mirantis account to your fuel deployment. So that makes it easier for support actually to gather information when they want to help you if you have an issue. Top right language, English. I think it's the rest is Chinese, Korean, and Japanese. Might not be in that order, but I think that's what it is in terms of language. Here is the number of nodes that I have and the number of unallocated nodes. In my case, I have no environment created, so I have 12 nodes. I have 6 Ceph nodes. I have 3 compute, 1 controller, 1 LMA node, and 1 MongoDB node for Salameter. If I had 30 and I had an environment created using 15, I would have, total nodes 30 and allocated 15. So this is my user account, my username. So I have logged in as admin. I can change the password here to make Fuel happy. And this is the event window. So basically, anything that happens is going to show up here. If I do a view all, you'll see everything that was discovered, everything I did. When I rebooted my environment, everything's going to be show up here, so you know what happened and what's going on. If you click on it, you go in detail. You know it was linked to which node and what, so you know in detail to which node it was related. Next step is creating actually the environment. So just click on the environment, give it a name, DemoStack. On our case, the only OpenStack release we can get is Kilo on Ubuntu. In MOS 8, you'll be able to get Liberty on Ubuntu and CentOS. So we're going to hit next, compute. In our case, we want KVM. If you're using like VirtualBox or stuff like that, you can use QEMU. If you want to tie in, actually consume vCenter resources, you can check that box, but by doing so, you'll need to use Nova Network in the next step as you're networking. Unless you go full VXLAN, and then you can use the NSXV and DVS plugin that we have for vCenter. So meaning that your overlay will be VXLAN, and you will use NSX inside your VMware environment. Networking, VLAN, VXLAN, or legacy network, Nova network. MOS 8, Mirantis OpenStack 8 will actually remove this legacy part completely. So anything we do with VMware will be plugin based with NSX and all the rest to give feature parity in terms of just not running a flat network, but actually being able to enable all the features of the environment, of the VMware environment. In our case, we're going to use VLAN instead of VXLAN. There's also GRE for tunneling segmentation that's available. The GRE part is now being pushed to the Fuel CLI, meaning that you have to change your networking that you created with VXLAN, and then when it's created, you go back on the Fuel CLI and it changes to GRE. So VLAN supports 4095 networks, VXLAN 16 millions, and GRE was I think 45,000. But the overhead with GRE is creating a bit of an issue, so that ends the push to VXLAN. Segmentation is basically linked to your tenant networks. So as a tenant, I have my own private network of a private IP range, but my neighbor tenant can actually have that same private range on his own. So we need to find a way that my VM running on compute 1 can talk to a VM running on compute 4 through that private network. So in our case, a VLAN tag is going to be put, and that's something you define in your network later on. We'll cover that in the next steps. Storage. You can use a default provider, default being Swift and Cinder. Glance will actually use local storage. In our case, Cinder, we can actually check the box to use Cinder LVM, so you'll have live migration through shared storage. So basic OpenStack storage. In our case, we're going to use Ceph. If we use Ceph, basically everything, Glance, Glance, Nova for ephemeral, Cinder, and Swift will actually use all the Ceph mechanism so nothing will actually be stored on the controllers or on the compute. Um, so basically, all the Ceph RBD, so Rados block device will be there, and the Rados gateway will actually be used for the Swift API. We have additional services we can put in place, and that's going to be our case. So Sahara, which is a big data as a service kind of, so help you build more dynamically Hadoop clusters for analytics. Murano is an application catalog, so it's more of a like, I want WordPress, push the button, it deploys. As an admin, you build that catalog and you offer it to your users, so they can easily consume it and tie in like all the elements that you want. Dev teams can actually use it to do more version of their apps, V1, V2, or anything. Versioning will actually be introduced in the next release. Salameter is the telemetry part, so it's metering, monitoring, also linked to the application, and also the heat templates. Heat allows for elasticity of an application also. So if Salameter gets data saying, load of this application or X is at 60%, maybe your trigger is saying that at 60% I need my application to scale. So that will trigger that action through those metrics, and will stretch your app if your app is actually made to be elastic. And finish. So we're just going to create the environment. Pretty straightforward. And next step, actually, we're going to go in detail in the demo environment, the demo stack. Okay, so now we're ready to actually build our environment. Now we are at the welcome page for our new OpenStack environment called Demo Stack. If I want to change the name, I can do it right here. I can also delete the environment. I won't do that yet. What I want to do actually is, add nodes and configure my environment. So before I go in the other setting, I'm just going to try to add nodes and show you the assigned roles that we have. So we can have controllers, compute. We've chosen to use Ceph, so the Cinder part is completely, deactivated. We have storage, so Ceph OSDs, and telemetry MongoDB. Also, the operating system, which is just the base OS without additional packages and configurations, is just if you want to, let's say, if you want to have a single pane of glass showing you all your compute, even though this one is not tied to an OpenStack environment per se, and it's like being managed by Neutron, you can actually do that. And here are all my 12 nodes discovered there with their MAC address at the end and all their specs, so I can assign them role. One thing though is that I've talked about plugin earlier on. Those plugins are installed, but some certain plugins gives you new roles to assign to a node. Problem here right now, they're not showing up. So what needs to be done, and we're going to do that next, is actually go in settings right here and turn those features on so we can have those access defined. So access, again, another place to change the user password for the admin tenant. Additional components, our Murano Salameter, they're still there. Salameter uses MongoDB. If I already have a MongoDB cluster in-house that can be link up to this environment, so then it can be used. So when you click it, it's actually going to tell you that this thing just popped up, and then you put in your information. It's not the case for us, so it's going to go away. Murano setting, that's the URL for the application catalog. Right now it's pointing to the official URL of the application catalog on the openstack.org site. You can actually find other apps online like in GitHub, stuff like that. Of course, whatever's set up in GitHub, we don't know, so be aware. The rest you can actually just trust what's in there. Common settings, if you wanna put quotas in place for tenant, puts more load on the Nova database, but if you really want to make sure that they don't consume everything, and then you can Nova quotas is a good thing. In my case, I'm just doing a test, so I don't need it. Puppet and debug, it's always nice, but requires more disk. Again, same thing for OpenStack. If you're actually testing your environment, if you want to play with it and see what's going on, strongly suggest that you turn those two guys on, so that way you see what's going on in detail. You get more visibility. Public key here at the bottom. Again, well, we can change the hypervisor, but the public key here at the bottom, important thing, this actually injects a SSH key to every node that you have, so you can have direct access. By default, Fuel acts as a jump server. So you log in, you SSH to Fuel, and then you can SSH, node, I don't know, like node 25 would be compute tree. Then, you can log in on it and do your thing, or hit your controllers if you want to modify anything. This is great for, testing the environment, having direct access. In production, I would suggest going another way than this. Unless you don't have any other choice for access, then please, use it, but with caution. If it's actually, makes your node able to be logged in by anybody, you can actually get the key or hack it. So just be aware. But great feature for, again, same thing as the logging and debugging. If you want to have direct access, great feature for logging in on your nodes directly. Kernel parameters, if you need to change anything, on the control, on the kernel, not the control, sorry. Neutron advanced config, the DVR part. So DVR introduced the notion of distributed virtual routers, supposed to help, not just supposed, but helping Neutron offload Neutron of some traffic by putting a virtual router on every compute. Like east-west traffic goes from compute to compute without having to hit Neutron all the time. So just make things a lot easier. But if you do so, if you click it, the firewall as a service and VPN as a service actually says, well, DVR must be disabled in order to use that. So probably both, yeah. So in our case, we want to use those features, and I'm just doing a test, so I don't need DVR. Just take it off. Fuel act syslog. So the Fuel act as a syslog server by default, so we'll gather all the log itself. So if you don't have a syslog server in house, it's a good thing to do. Just think about storage space for your Fuel node. That's important. So if you already have a syslog server in house, you can just put the host name there in the port, and that's actually going to forward the log to it. If you're using the LMA part, you can actually just leave that blank, and the LMA plugin will take care of the rest. Public network assignment basically allows for every node to be reachable via the network, the public network. Right now, it's only the controllers that are. And unless you have a specific case for having public network on all your nodes, just leave it unchecked. Repositories is where all the packages that we fetch to build the images for deploying are actually stored. We go fetch straight from Ubuntu. In there, the rest is Mirantis based URL, and this one is a local one for some specific packages that we might need. So everything is in there. Storage. We've said no sender, so it's not checked. So in the rest is all Ceph RBD. That's defined. So Rados block device are there, and the Rados gateway is there. We want 3 replication for replication factor. So we'll just put that in. Now we're hitting the plugin part. So the plugin part, I want my Kibana server. I said I want the LMA stack because I want in this demo to show actually this plugin and VPN and firewall working. So Elasticsearch, I want it activated. VPN as a service, again, same thing. Firewall, super simple. And the LMA part, so yes, I want that. I have a demo stack. This label, whoa, okay. Sorry. Demo stack. This is the environment label, basically that allows you in your log dashboard to see from which environment it's coming. So if you already have like an Elasticsearch server in-house, that will tag all the information regarding to your stack when it's passed to that Elasticsearch server, meaning that you'll know from which stack actually is coming. So if you have, I don't know, like 5 fuel environment and it's demo stack 1 to 5, then you can tag them demo stack 1 to 5, and if they're all pointing to a same centralized Elasticsearch server, then you can use that. If you actually build one of those environments with LMA fully installed and you just want the others to point to it, then first environment, is actually what we're doing right now. Local mode, no address here, no information to put in there. I want alerting to, that's for email notification, things like that, to send it to a local infrastructure, so the local LMA deployment we're going to have. So that's the case here, so I just need to do that. So if that's the first one and you want to use that feature, like your first environment could actually be set up like that, and the other environment, you can actually make it point to that server if that IP is actually reachable from your new environment. LDAP. So if you want LDAP authentication plugin backend for Keystone, that's where you activate it, and then you put in all your information of where you want to log in. It could be a real LDAP server or open LDAP server. It can be LDAP features activated on a AD Active Directory server. Could be, personally, when I do just raw testing in the lab online, I use something called Jump Cloud. It's an online service that allows like for 10 accounts for free, and I put the information there so I can just test, actually show that yes, you can log in using a domain, and your users you're defining in there are actually the one that you're using to log in into your environment. So if you need it, you activate the LDAP plugin, fill in the information. If you are unsure, then actually everything that's in there becomes a file on the controllers, so that's something that can be manually modified after, in case you have issues with your config. In our case, we're not going to activate it here. The LMA part, again, continuing. So Nagios itself will put a root me password, Nagios admin. We want a recipient, so let's put my CloudOps email address, and here we're going to say it's LMA at demo stack, and a local host. Here, the rest, no authentication, no SMTP user, anything, so just save the settings. Next step is the InfluxDB Grafana server. So I want to activate that. Root password for this, just keep it simple. I'm gonna just put LMA1, so that way everything is okay. Again, saving it, we're good. Next step is the OSOS DNS server. So for every server that's deployed, every node, DNS server, right now it's Google. Let's add also the second one, 8.8.4.4. So that's done. And if you have a local one that's reachable, you can use it. This is for the NTP server. So basically, right now Fuel is your NTP server. Next step, and the last one in terms of setting, is the public TLS. So public TLS actually offers you HTTPS or TLS termination for for Horizon itself. So people will log in HTTPS in Horizon, and also TLS terminations for HA proxy for the OpenStack services. So all the OpenStack services that sits behind HA proxy, that HA proxy will have a certificate. And then from there, after that, will go clear, but you're going to hit those environment in HTTPS, those APIs endpoint. So you can use the public fuel local, that's it. You can actually provide your own certificate if you have one, and then put the full FQDN here. In our case, we're going to go with a self-sign, and since mine is actually sitting on a lab on the internet, I need to specify the information for that node. So I'm just going to put that in for my controller, get that information, paste it back in. So I'm using Revelo, so ravcloud.com for revelosystems.com for my lab, for my controller. So this is where that's going to be my URL for Horizon later on. So public TLS is there. Everything has been saved. We're there. So interesting thing now, if we go back to nodes, and I have nothing assigned yet. Now, if I add nodes, magically I have more roles that just came up, especially the LMA one that are showing. Without activating it, I can actually use it. So now it's activated, so I can actually use it properly, and actually I can start assigning them to a node himself. My LMA node actually has a MAC address that ends with 0100, so that's this one. I'm gonna do it clean and call it LMA. So that's this, and it's covered. It's done. My next one is going to be my MongoDB. MongoDB is 8.0, so I'm going to just add a node, say, well, I want Mongo. Go and get my 8.0 here. There you go. Yep, check that in. So let's call that MongoDB. All right, apply. Next one's going to be my controller. My controller I know is always 00, so it's right here. So just a controller. All right, so this one is good. So far I have my controller, Mongo, and LMA defined. Next one would be nice to have some compute. So if I'm not mistaken, my compute are 2, 3, and 7. So 2, 3, and 7 are my compute. So selected. I'm not gonna do the rename for this one. So it's there. Then storage would be nice. So this is my storage. Apply the change. So everything is there and working. So now this is the look of my environment. Set my 6 Ceph nodes, 3 compute, 1 telemetry, 1 LMA, 1 controller. So this is all good, but I need to make sure the networking actually is set up properly. So if I select them all, if I do configure interfaces, it's going to bring me the network environment. My environment is I have 5 NICs per servers, only 1 gig. So I've put 1 for each. So if I add like 10 gigs, I could actually maybe aggregate them and do something. And that's a feature that we have. Like if I need to bond interfaces, I can do that and select what type of do I want active backup? Do I want link aggregation like LACP? So I would fall to 2 gigs, or if I have 210s like 20, or balance round robin if I have active. In my case, I'm not using bonded, so I'm gonna unbond the interface. But that's a great feature. If I'm not mistaken, the only thing you cannot do is that you cannot bond interfaces where the Pixie server, the Pixie interface actually is. So in my case, I know that my mapping is actually like this. So this is my network. You can see actually that right now it's defining some VLANs in some of my interfaces. That's something that's going to change. I need to provide that proper VLAN info, and that's done in the network tab here at top. That's going to be our next our next stop in terms of networking. So back to node list. So I can unselect it all. If I go networking, this is the public part. So no VLAN tagging. That's not a problem. In my case, I have 1 NIC per function. I don't need the VLANs. What I need though is the part for VLAN segmentation. So my VLAN segmentation that I did on my switch on my lab, it's 110 to 119. So pretty straightforward. It's a limited amount of tenants, but that's all I needed for my test environment. So I don't need more. So that's perfect. So I'm gonna save that. So that's done, and we're gonna come back to this little graph here once I want to finish something with the nodes first. So going back to nodes. One thing that we are missing in the Ceph OSD part is actually journaling. So I need to tweak the hard drive. So I'm going to select them all because they're all the same, so I don't have to worry. You can see that the storage is the same, everything is the same. So I'm going to configure the disk. Right now I only have like, I have the two drives. So I'm faking like a 3 drive system, like the OS part, and then two other spinning drives of 200 gigs. So this is unallocated, so waste of space. So what I want to do, to click on it, I can either stretch my base system, which would be useless, could actually reclaim it for Ceph, so for Ceph block storage. But I want to journal. So journaling, there you go, apply. And by doing so, I've selected all the drives. So this has been done on all the 6 nodes and, good to go. So back to node list. Uh, if I take any one of them and I say configure disk, you can actually see that it's been done. In terms of the controller, we can see the partition of the disk. Base system logs MySQL. If I want to stretch that part for, let's give it a bit for MySQL. Let's give it a lot more for the logs, and maybe boost the base system a bit just in case. Can do this, and MySQL database always needs space. You just drop the log a bit and do this like that. There you go. All right, so that's optimizing my storage for everything I have, like something like telemetry. If you go configure disk, you'll see it's based on Mongo. It takes everything. For Kibana, it's Kibana, the LMA. It's something similar. You'll see for every function, the space that they have. In terms of compute, if I select them all and go configure disk, you'll see it's just virtual storage and base system. Virtual storage will probably be used at one point when you select an image for the first time, it kind of copies it locally when it's spun, and then it needs that space. So it's going to consume that part too. So my storage is done. My network is mapped. So it's a good thing. Next, I wanted to go back to networking. So just if I go back to dashboard now, I can see the name of the stack. It's a new stack, KVM, VLAN segmentation, everything that's been set up there. I can still add nodes. I don't have any more nodes, but I can still delete the environment. I don't want to do that. And it gives you capacity. So you know that you'll have 32 CPU cores, 4.6 terabyte of storage, and 104 gig of RAM. Total nodes, controller layouts are giving you, and it's pending addition. So I'm pending 12 nodes addition for this environment. I have 1 controller. So if I wanted to go to a full HA stack with 3 controllers, if I were to add 2 more nodes, I would have the possibility after I've deployed, to add those 2 nodes and go from a single stack to a full HA stack. And pending addition on the deployed environment would be like those 2 nodes pending. And when I do that, it would actually make my stack from non-HA to HA, and downtime in terms of it's going to be API related, and it's going to be really quick. It's just when actually the HA proxy and everything else rebalance itself so that it includes the new members in that cluster, so it can be like really like a micro cut. One of the things that it says like at least if you do an HA, 3 controllers. So if you do go HA, also 3 Mongo nodes are also recommended for an HA deployment. Of course, it just makes sense. In our case, it's not the case, but it's just show you the recommendation if you don't apply them. It's also recommended to do a verified network, which is actually what we want to do next. So I've set up my environment, everything is there. One of the great features of Fuel is actually that, once you're ready to deploy, you want to have this guy giving you, it's all green, let's go. So if I do a verify network, it's going to try to get traffic through with the configuration I gave him, like VLAN wise and everything. So if I'm expecting, in my case, I have no VLAN, so beside the 110 to 119, but let's say management was VLAN 102. If I'm trying to generate traffic and tag traffic 102, and actually the switch is telling me, I don't know 102, so it's missing. I can't talk 102 on this port, then it will actually show up. So it validates that the switch has been configured properly and that your environment will actually be able to handle that type of traffic. Okay, now the verification is succeeded and my network is configured properly. So I got green, it's all good. Just going on top also, you have the logs of what's going on in the field master. When they test Mac and everything, everything's going to show when we assign things. So when it does testing and everything, you'll see everything. Right now, everything is good. You have the fuel master, you have all the other servers. When you change the name, it helps in the node because like LMA controller Mongo actually helps a lot to have the mayor. And then is it an M collective information or DMAT or whatever needed, and then you can boost the login level to see more. Last tab is the L check one. The L check is something that's great once you've deployed. Of course, it will actually do a sanity check and perform real OpenStack actions against your stack to see if it behaves properly, like creating image, creating snapshot volumes, getting a list of instances, running Nova, create create like Sarah test, create a Murano test, make sure the application is working, attaching a floating IP and everything and so on and so on. Testing the HA part also, making sure everything is okay, and RabbitMQ and everything in there. So that's something you can run once you've deployed your environment, and we'll do that. I will get some red at many places, and I'll explain why also and how you can fix it. So now that everything is good, I can hit deploy change, and we'll see how it goes. So basically what's going to happen is that the first things are that the node's going to be prepped, and they're going to boot and start fetching images. They're going to get the images from the fuel node that builds the Ubuntu image for everything that's needed. That contains the Puppet information also regarding that role that they have, and they will be prepped as compute controllers, Ceph OSDs, LMA, and everything. So right now we can see I'm installing Ubuntu, and after that I'm gonna go back to install OpenStack, and then after that, once everything is okay, then I'll get my my stack up and running. So in terms of recording and time consuming, I will just stop at this part, and we'll pick up once the stack is completely deployed. So again, it's going to say installing Ubuntu, and then after that, it's going to go to install OpenStack. And once OpenStack is installed, and that's a granular installation, basically if you were to be in a HA setting, your controllers would all be ready. At one point, we'll install the controllers up to 60%, and now it's gonna, after that, it's gonna install all the RabbitMQ and everything services and build that cluster to make sure everything is okay. Then once your control plane is okay, compute and storage will be added up, to the stack. So again, installing Ubuntu, installing OpenStack, and then we're ready to go, and we can actually do a health check. So I'll come back when I'll resume the recording when this is done. You have also the possibility of having a compact view, which is nice when you don't have like a 4K screen to give you the perfect resolution to see everything, and then from there you can actually have the state of everything, and you can also see the logs of what's going on, like I did earlier on when you go in the log tab. Just gives you a shortcut to goes directly to the node itself. So we'll let it run, and we'll resume when the OpenStack is actually completely installed.